Hello everyone. So in today's video we are going to solve a very popular Leetcode question called single number 3. So in this question we are provided with an array and we need to return two numbers which are repeating exactly one time in this array. Rest of the numbers are repeating exactly two times and there are two numbers which are repeating exactly one time and our job is to repeat those two numbers. So let's have a look at this array. So we got 1 2 1 3 to 5. So if you see, we have 1 and 1 repeating two times. Then we have 2 and 2 repeating two times. Then we are left with 3 and 5, which are repeating exactly one time. So our task is to return the solution as 3 and 5. So there can be multiple ways of solving this problem. So the very trivial approach would be count the frequency of each number and then check like which number has frequency of 1 and return the array of that number. So if you make a hash map, then the frequency of 1 will be 2, 2 will be 2, and 3 will be 1, and 5 will be 1. So we will take the frequency of 1 and return those corresponding numbers. So that can be one way of solving that. But for today's video, we are not going to use hash map. We are going to use bit manipulation for solving it. And trust me, it is going to be very interesting if you solve using bit manipulation. So for solving this question, we are primarily going to use XOR operator. So before beginning, let's have a quick look at the truth table for the XOR. So let me explain it simply. So if your input bits are same, you are going to get output as 0. If your input bits are differing, like 1 or 0, then your output is going to be 1. So if you look here, if you take a look at here, your input is A and B is 0 and 0, then A or B is 0. If input is 1 and 0, then output is 1. Input is 0 and 1, then output is 1. Even if input is 1 and 1, the output is 0. So basically it is telling that if bits are different, the output is going to be 1, and if bits are same, the output is going to be 0. So this was the basic truth table. Now let's have a look at some property of XOR operator. So if you have a look, if you do XOR of any number with itself, you are going to always get 0. If you have look at here, if you look here, you can see we are doing XOR of 0 and 0. It is resulting in 0. We are doing XOR of 1 and 1. It is resulting in 0. Then there is one more property which says if you do XOR of any number with 0, you are going to get that number. Okay. So let's verify this first property. So for example, I've taken 7 as decimal, 7 number. So binary representation for 7 is 111. So if you do 7 XOR 0, 7 XOR 7, which basically is 111 XOR 111, then you are going to get 000. So this was clear. Now let's see what's the benefit of XOR or how it is going to help us in solving this problem. So we can use XOR operator to basically remove the duplicates. So if we do XOR operator on this entire array, it is going to cancel out the number which are repeating two times. So here you can see we are doing 1 XOR 1 XOR 2 XOR 2 XOR 3 XOR 5. So it is going to cancel out 1 here, then 2 here. Then our final result will be 3 XOR 5. Okay. So now you can see that we have removed the repeated numbers, but instead of finding these numbers, we have the XOR of these two numbers. Okay, this problem seems that it has been solved, but it has not been solved yet. Now, what we can do is, uh, okay, so okay, let's move to the next step. So now our job is to find the what we say differing bit. Uh, Wait a second. Let me put it this way. So we have our XOR operator, we have our result, which is basically 3 or 5. So we are going to find the first position where bit of these two numbers is going to be different. So let's convert it to binary. So binary representation for 3 is 1 1. Then binary representation for 5 is 101. If we do XOR here, you can see we are getting 110, which is basically 6. Okay, but if you have look here, you can see if two numbers are different, then there must be at least one position where their bit is going to differ. So in this case, the differing bit is second position. So it start with second position. Then we also have a differing bit at third position. So let's see how we can use this property to solve this question further. So let's see our observation. So observation stated that if the numbers are different, if the numbers are different, there must be at least one bit position where bits from both numbers will differ. So if you see here, if you take 3 and 5, you can see in the second position our 3 has 1 here, but our 5 has 0 here. And in at the third position, our 3 has 0 here and 5 has 1 here. So let's use this property to further solve this question. That's basically same thing, which is saying that our first differing bit is at second position. Okay. So now what we can do is we can divide this entire array into two groups based on the differing bits. So what we can do is we can take this entire array. So I've converted this entire array to their binary representation. So one becomes 0 0 1, 2 becomes 1 0 1 0 1 0, and then 3 becomes 1 1 1. So like this, I've created the binary representation, and then based on the second position of each bit, I have categorized this array. So you can see here we have all arrays, all number whose second bit is 0. So our 1, 1 and 5 have their second bit at 0. Then if you look at the second group, you can see their second position is all 1, which is 3, 2, 2. So 3, 2, 2 have their second bit as 1. So now you can see we have clearly our 5 and 3 into two separate groups, but we also have some repeating numbers with, like 1, 1, 2, 2. So now it is very simple from here to solve this question. So what we are going to do is we are going to simply do XOR operator in these two groups. So if you do XOR of 1, 1, 5, then 1, 1 is going to cancel out each other and we are going to left with 5. Then for the second group, now wait a second, let me change this number. Yeah, so it is second number. So second number will become 2 XOR 2 XOR 3. So 2 and 2 is going to cancel out each other. And then at the end, we are going to left with 3. So our final solution becomes 5 and 3. But now if you ask, okay, you sim now if you now you would question like how do I find what is a differing bit? Okay, here I simply mentioned that we have to find the first position where both bits differ, but how we are going to exactly do that? So let me explain that quickly. So there can be multiple ways. So there can be multiple way. Either you can use loop, you can iterate manually through the both number and check whether the where is the first differing bit coming. So it is going to take a lot of time and the complexity would be, I think, constant of 32. There is a better solution. There is a better way of getting the first differing bit in a number. So if you take a number and do end with the negative of that number, you are going to get the first differing bit. So if you so our number was 3 or 5, which is basically 6. So in 6, we know that the second bit is the first differing bit. But how do we get it exactly? So after putting in this formula, which is 110 in binary representation, then end with the negative of this number. So converting this number to negative is entirely different thing. I think a whole video can be made on that also. But for just knowledge, I can tell you that for converting any number into negative, what we have to do is first we have to flip all of its bit, which is basically converting it to its first complement. Then we have to add one to make it second complement. So that's the process for converting any number into negative representation of its binary. So first flip every bit and then add one. So if you see here, first we have flipped every bit. So this becomes 0 0 1, 0 0 1. And then if we add one here, so there was already a one here. So it will carry out here, it will go one, that one will go here and it will become 0 here. And then if we do AND operator with this. You can see 0, 0 and 0 is going to be 0, then 1 and 1 is going to be 1, and then 0, 1 and 0 is going to be 0. So this number basically tells that the second, okay, so this number basically has the second bit as high, and we can use this as mask for categorizing both numbers. So what we can do is we can take any number, let's say 1, and we will do or with this, what we say, yeah, we will do and with number, and with this number. So let's say, let's take two examples. So first we are going to take 2 and then we are going to take 5. So binary representation for 2 is 101 and for 5 is 101. Okay, 2 for 2 it was 010 and our mask was 101. Okay, then if you do AND of 2 with this number, which is basically 101, you are going to get a number called, you are going to get a number 101, 010. Then if you do AND with 5, let me clear it a little bit. You are going to get 0, 0, 0. Okay, so we can use this condition to categorize our number. So after doing AND with this mask, if we are getting any number which is not 0, it will become one category, and any number which becomes 0, it will become second category. So this was gist of it. Now let's try to solve this question. Okay, so solving this question will make it more clear. Okay, so we have our lead code question here. You can go through this question if you want. So first start by making the array itself. We are going to use malloc. This is just boilerplate code. You can ignore this or you can adapt it to any programming language which you use. Let's say size of int, and then we are going to have two number as output. I think this is it. Now let's first get the XOR of each and every number. So for that, let me create a variable called XOR. Okay, before that, let me return the ARR, or even better, I should rename it to, let's say, result. Okay, now let's try to run this question, run this code. Okay, we don't have any error. You can do one thing. If you try to solve any question, try to run this question after writing some line of code. So in that way, you can know that whether there is any error or not. I'm not talking about logical error. I'm talking about syntactical error. Okay, so that one thing you can use. So now let's create a variable called XOR. I don't know whether this name is good enough or not, but I will initialize it with 0. Then I will make a loop. It will go till the num size. Now I will do XOR equal to XOR and then my num set I. You can either write this way or you can use a shorthand operator, which is basically both the same thing. Okay, now let's print this value to for our sake of understanding, just to see what value we are getting. If I do printf, what I'm writing, what man, percentage d comma let's say dot I to run it. What happened? Okay, it's not zod, it's xor. Okay, we can see that we are getting our zod result is 6, which is basically 3 zod 5. Okay, so till here we are getting everything correct. Now let's find the first different bit. So let's create another variable called int least. So I have named this variable called least significant set bit. Set bit is basically one way of telling that that particular bit is 1. Okay, so that will become XOR XOR and minus XOR. So it is going to give us a number called 2. So let's print that out. It should give us 2. Let's see. Yeah, so it is giving us 2. So now we have our binary mask. So we are going to use this mask, which is least significant set bit, to categorize both numbers. Okay. So now simply I'm going to run another loop. Let me copy this one. It will run from I equal to 0 to okay. Now inside here, we are going to write a conditional check to categorize this number. So we will take the number which is ARR of, oh no, it's not ARR, it's nums of I. If nums of I and our least significant set bit is equal to 1, it will be the first group. So what we are going to do is we are going to store the XOR of these numbers into our result directly. So our results, our results of 0 is equal to result of 0 XOR nums of I. So this is going to store the first number and it will do the XOR simultaneously. So these will be the numbers which have their second bit as 1. Now we will going to also store the second number whose second bit is 0. Then we will put an else condition and we are going to put the same thing here. We are just going to change the arrow location. Now let's see whether we got this question correct or not. Okay, we have our okay. We also need to return the size of the array, which is basically this one. So I will quickly dereference it. Then I will put 2 as the size. Okay, we have interesting. Let's see what the issue is. Okay, I got it. So if you realize here, we are doing XOR operator. Okay, so this variable, so this value here first, it is going to have some random value because we have not initialized this value with 0. So we are going to first initialize it with 0. So we are going to do same thing. We are going to copy this. Then we will put this is equal to 0. Then same thing we are going to put here 0. Yeah, I think now it should work. Okay, we got one more issue why we are having 0 here. Also, I found this issue. So there was a precedence issue. So I think it is solving from here. So it was first doing this comparison, then it was doing this comparison. So let us put this inside a bracket and it should work now. Yep, it works now. Let's try to submit it. What runtime cannot be represented in okay. We are getting. I think we should increase our variable size. Where else is this? Okay. Yeah, so it has passed.